Good morning, everybody. Can you hear me at the back? Can you hear me at the back? It's good, because I mumble a bit, so stick your hand up if I don't talk loudly enough. Thanks for that introduction. So we've just heard Adrian talking about the use of CIPC and how vital it is for the industry. And if we go back 5 or 6 years, or perhaps even a little bit longer, there's a genuine threat that CIPC would be withdrawn from use. And for reasons that we know about. And AHDB Potatoes and the industry took the view that they ought to mitigate that problem, and they did it in 2 ways. The first is the way that Adrian has just discussed. That's how can we use CIPC more effectively, more efficiently, so that we're reducing the amount that is being applied and getting better results from it, and minimizing the threat of residue levels. The other way was to try to either move away from CIPC or find some method that you could use CIPC in combination with some other treatment. So although this talk, the title was the use of ethylene to supplement CIPC, in the first part of it I'll talk about the use of ethylene on its own, because I think it was an important piece of work that was sponsored by, as is now, AHDB Potatoes, and many collaborators in this DEFRA-Link piece of research. And there were 3 components to that. The first was a long-term strategy. Can we breed potatoes with longer dormancy? And that work was being done by the James Hutton Institute. The next was a short to medium term. Can we find some alternative sprout suppressants, work largely carried out by Natural Resources International, University of Greenwich. And the final one, and the one that I'm going to talk about, is a short-term solution. Can we develop a sprout control strategy that uses ethylene and, if required, some other treatment? So going back a while, ethylene was known that you could use it as a sprout suppressant. It was used in cold stores. But the problem is it has a strong varietal dependence, and it also affects the processing colour. So particularly when it's stored cold, the addition of ethylene increases the respiration rate up, and we start to see effects in processing colour. So we know there's a genetic range in response to ethylene. Can we identify processing varieties, in which ethylene might be a suitable sprout control agent without adversely affecting processing quality? So here, this is just the materials and methods. So here we're taking a wide range of processing varieties. We're storing them all at the same temperature, 9 degrees. So because this was done in a collective store, all the varieties go into the same store, so we couldn't deal with them independently. There's plenty of replication. As Adrian said, we did some in trays, some in boxes, and some in bulk piles. So we've actually replicated these experiments in all 3 systems. Best practice was to increase the ethylene from 0 to 10 parts per million over a ramped period of a couple of weeks. So we had the potatoes in the store, added some ethylene to them gradually, and then assessed them every two months for sprouting and for processing colour. And this is one result, and I've put it up for Maris Piper here because it's such a key variety, and it starts to illustrate some of the problems that we have. So here, this is untreated, and this top graph is for sprouting. These are untreated, and this is where we've got 10 parts per million ethylene, and these are the sprout lengths. So if we were to take, say, 10 millimeters as a sprout length to be a sort of cut-off, we can see that untreated is growing into big plants, but ethylene is not controlling the sprouting of Maris piper. But it seems to have actually no effect on the processing colour. So this is where they've been fried as chips, and this range is USDA 0. So the addition of ethylene has absolutely a really small effect on the processing colour. So if we can find some way of improving the sprout control of Maris piper, then we could use ethylene with it without any deleterious consequences. And this one is Russet Burbank. I've put it up because it's a very good example of a variety that's both well controlled. The sprouting is well controlled by ethylene without too much effect on processing quality. Oh, let's just go back. So this is 2, 4, and 6 months, and you can see that actually sprouting is really pretty well controlled for 6 months. There's an initial effect of ethylene on the processing quality, again in terms of chips, but 3 is 0. So we're actually only looking at perhaps half, probably less than that of a USDA colour digit. This is some examples of ethylene in bulk, where these different varieties were netted into a bulk pile of, I think, marquees. So that's an example of the chip colour after 6 months. And below, in the graph here, this is actually the sprout length. And we can see that Marquise, Ramos, and Burbank are really well controlled by ethylene without adversely being affected, the chip colour. Well, you might disagree, you might say that that's adversely affected. Innovator is not well controlled after 2 months. So at 4 months, the sprouting is starting to be quite uncontrolled. There's 2 crisping varieties, Claire and VR808. I'd have to say that the sprout, you might say that sprouting at 6 months is just about acceptable with 808. And the crisp colour is okay, is adequate. So this is a big, complicated table of all the varieties we've got. I don't know if you can see that they're red and green. Red means that we think they're the criteria that we've used in terms of either sprout length or processing quality, then they fall outside that. But we can see that most varieties, for processing, the criteria we've used is a USDA score of less than 1, Sutton Bridge score of less than 4, and sprouting we've taken as 10 millimetre. I haven't put the untreated sprout lengths up. They sprout like crazy at 9 degrees, as you can well imagine. But in every instance, ethylene does reduce the sprout length, but not necessarily to a commercial value. But what you can say is that there are some, it's got to be green. There are some varieties where we can clearly see ethylene has both good control of sprouting and no real effect on processing quality, or although there's an effect, it still gives an acceptable product. Okay, and this is up to 6 months storage. So the summary for that piece of work really was that ethylene reduces sprouting in all varieties, so it's a well-known, it can be used, but not necessarily to commercially useful strength, as it were. There's a pronounced varietal response to ethylene. I think we already knew that. We find the same results so that it can be replicated in boxes and in bulk. And ethylene may cause an increase in fry colour in some but not all varieties, but that fry colour increase is relatively small. and usually doesn't make the difference between commercially unacceptable and acceptable. So this is the sort of some more recent work that we've been doing, where we've been using a combination of ethylene and CIPC. I should say this work fell out of the previous DEFRA link work pretty much. So again, we're characterizing varieties. Again, we've used 9 degrees C as a standard storage treatment. These are stored in boxes within a bulk of marquees. And there are 3 treatments. So there's ethylene and 9 ppm CIPC. So that's a single dose. That's a quarter that will be able to be used in 2017. So it's actually quite a small initial dose, and that's it. Ethylene on its own and the same dose of CIPC on its own. Again, we ramp the ethylene, which is best practice. We've used the restrain system. There are 2 different ethylene production systems, restrain and biofresh. And again, at 2 monthly intervals, we assess for how they sprout and for the process and colour. So this is Maris Piper again. And here we've already seen what ethylene does to it or doesn't do to it in terms of sprout length. So here in this top panel, this is sprout length with CIPC or CIPC and ethylene alone. CIPC alone or CIPC and ethylene. And we can clearly see that sprout has been really well controlled by CIPC, and if anything, it's even better controlled by CIPC and ethylene. And so this is 9 parts per million of CIPC over 6 months. And once again, the effect of ethylene, which is here, I think it's fallen off the bottom of my presentation. Apologies for that. So this is CIPC and ethylene, and there's no significant difference in those chip values compared to CIPC alone. Similarly with Burbank, CIPC and ethylene provides a better level of sprout suppression than CIPC alone, but having said that, CIPC fairly well adequate. But here we see there is a small initial increase over 2 and 4 months of fry colour. But that's, again, it's less than about half a USDA unit, and it falls back to something approaching that with CIPC alone after 6 months. And that's something that we quite often find. There's an initial slightly higher colour with ethylene, and that effect diminishes over storage period. So this is that collection of variety tables. So we've got sprout length, process and colour, and ethylene, CIPC, and CIPC alone. I think you'll probably, I don't know if you can remember, about 4 slides back where I did this for ethylene, but here we can compare ethylene and CIPC and ethylene, or CIPC and ethylene and CIPC. And generally, we see the best results are those where we've got ethylene and CIPC in combination. In almost every case, that's green for sprouting and green for processing colour. There are some varieties which are not controlled up to 6 months, so Lady Clare was one of those, Royal, and Royal. I think that's it. So what stands out for me here is that Maris Piper is really well controlled by a combination of CIPC and ethylene in comparison to CIP. Actually, I've now realised what I've done. I've actually mixed up a slide. This is actually the results for 9 parts per million CIPC. The other slide that I showed you was from a separate previous experiment. So needless to say, so CIPC and ethylene, we're getting really nice sprout suppression together and no effect on processing colour. So a combination treatment of CIPC and ethylene improves the sprout control compared to either of those sprout suppressants alone. Ethylene, the fry colour effect is that ethylene causes is irrespective of whether CIPC is there or not. So for some varieties, there's no statistically significant effect of ethylene on fry colour, whereas Fontaine, Ramos and Royal are significantly affected, and in particular are significantly affected over the first 1 or 2 storage periods. However, even where that ethylene has increased fry colour, it's still commercially acceptable within the parameters that we've set. So we think that this approach shows great promise for varieties that are inadequately controlled by ethylene alone, and which are not adversely fry colour affected by ethylene. And so Maris Piper would sit very comfortably in here. So I think what we can say is that irrespective of what's coming in the future with regards to CIPC, we know that we can use CIPC and ethylene, and we can use very small amounts of CIPC and still get good processing, adequate storage, or better than adequate storage. Okay. There's one additional treatment that we also tried, and this is 1-methylcyclopropene. It's called Smart Block. It's used widely in some other fruit and vegetable areas, particularly apple storage. And it's an antagonist of ethylene. So ethylene is a very complicated plant hormone. It's involved in all sorts of things: senescence, pathogen defense, and clearly sprouting and some sort of fry colour and respiration. So what this molecule here pretends it's ethylene and blocks the ethylene receptor for a period. So the ethylene receptor controls how ethylene is responded to by the plant. It doesn't have registration for potatoes, but so we'd previously used it and seen what we thought were beneficial effects, but we'd only used it at one particular concentration. So in this set of experiments I'm about to show you, we actually used 3 different concentrations. Standard thing, 9 degrees C storage and a gradual ethylene ramp. We were only able to do it for 2 varieties in this particular occasion, and we used Marquise and Russet Burbank, both of which we know sprout control is good, both of which we know that French fry colour is not significantly affected by ethylene. NRI, Natural Resources International, did some sugar analysis for us. Somewhat complicated slide, apologies. So this table on the left-hand side, we've got Marquise, Russet Burbank, 2-month storage, 4-month storage, and then the 4 different concentrations of 1 MCP, and our estimate of the French fry colour score. So these are all USDA 0 or less, and for Russet Burbank, they're all USDA 0. And you can clearly see that 1 MCP reduces the apparent fry colour of ethylene, ethylene treated marquees, but not for Russet Burbank. So this is another treatment that has a varietal component to it. So you might be able to use it for a particular variety, but you have to do it in an empirical fashion. So whereas CIPC, Smart Block, DMN, they all act on varieties pretty much irrespective, this is yet another treatment where there's a varietal component to it. These two panels on the right-hand side are to do with reducing sugars that are components to giving darkening of fry colours. So, and here we've got fructose, and it's an estimate of the concentration in a potato tuber. And you can see that with with marquees, we're getting this decrease in fructose at 2 months, and you can still see that decrease is present at 4 months. We can see a slight decrease with Russet Burbank, but that doesn't seem to manifest itself in a darkening of the fry colour. A decrease in fry colour. So I think that's quite interesting. We can see an effect on fry colour, and we can see an effect on sugar, and they both tell us that there's a varietal response. So if we wanted to use 1-MCP, we would have to do it by empirically working out whether it was a good option or not. So overall, I think the summary would be that varieties differ markedly in their response to ethylene. Ethylene reduces sprouting. There's an effect on fry colour. A combination of CIPC and ethylene does look to be a very effective treatment, and we can use very low amounts of CIPC. So 9 parts per million will give effective sprout control up to 6 months. 1-MCP has no effect on sprouting. I didn't show you that data, but may help to reduce the increase in fry colour caused by either ethylene treatment or some other trauma related to harvest. This work's continuing, so AHDB Potatoes have provided funds for us to repeat that work, and you'll see the results of that later this year. So I'd like to acknowledge the colleagues at Sutton Bridge. It's a team effort, really. AHDB Potatoes for funding the work, the DEFRA-Link Consortium for that earlier work, and Restrain. We've got Dirk Garros and Louise Ricks in the audience, and if you want to talk to them about ethylene, they've been very helpful to us. And thank you.
Thank you, Glyn. Do we have any questions? Jeff?
Yeah, Glyn, you've demonstrated that you can get good sprout control with ethylene. I think we knew that. You've also demonstrated that there's very little impact on fry colour on some potatoes in that trial. How can we be sure that that impact, or no impact, is due to the lot of potatoes that you've tested, and that every lot of, say, Maris Piper that you treat with ethylene going forward will have the same effect, or won't have an effect on fry colour? How can we be sure it's not the maturity of the crop, for example, that you've had in the trial? These experiments have been, particularly with ethylene alone, those have been replicated over 3 and 4 years, actually. So, for example, with marquees, we've run in bulk, we've run those experiments for 4 years, and find essentially the same types of results. So I think by replication is the answer. Okay.
Annual seasonal replication.
But there is other work that would suggest that there is an effect from ethylene on fry colour.
So that other work has been done at much lower temperatures. So at 6 degrees, we've done some work, And you do see an effect, a larger effect of fry colour, and clearly if the storage temperature is lower than that, there's a big effect. So what work are you alluding to?
Well, we've done some work within McCain on fry colour, both here in the UK and elsewhere.
Right. And which varieties have you been?
Primarily Russet Burbank, but in the UK we tested it on a number of varieties. And we saw the variable sprout control that you've shown.
Yeah.
But we also saw an effect on fry colour on Russet Burbank. So I'd be nervous about saying we can go out and treat Russet Burbank with ethylene. Are you going to be able to guarantee that we're not going to get an effect on fry colour?
Well,
just saying what Jeff says is what's the difference of taking your results from a small trial series
Yeah.
into a commercial situation of 1,000 tonnes of chicken material?
Well, we are where we are with it, really. I mean, it is actually, so perhaps we should get together with people that have been doing this commercially and actually try to work out what the difference is between storage and small scale, and I quite appreciate that, and the risk that people will take to store a much larger amount with ethylene. All I can say is that in our hands, in our storage conditions, these are the results that we're getting.
So just on that, so that's box storage. Obviously, your small trial box. Sorry, your small trial box storage, and is there any difference between box and bulk? Bearing in mind the majority of storage in processing is bulk.
So we find no difference between box and bulk for ethylene alone. We're only able to do box storage for ethylene CIPC in combination. But there's absolutely no difference that we can detect.
And how easy is ethylene to treat in the bulk storage?
It's a gas. It's
so it'll be
very
just the
easy.
same.
Yeah. Again, restrainer here if you wanted to ask that question. But in our hands, we have no problem in maintaining an atmosphere of ethylene.
Glyn, just a small point. My experience with the processing sector is that they vent their stores an awful lot.
Yes.
So is that not going to result in you getting very fluctuating ethylene levels? I know you spoke about 10 ppm,
Yeah.
but presumably if you vent as much as McCain's usually vent, for example, then presumably you've got to vamp it up to 10 again. So would the fluctuating ethylene not have an impact here?
So that's not something that we personally work on. We've just managed to control it. But some other work that we've done has shown that ethylene at much lower concentrations still suppresses sprouting. So you can go down to 4 ppm, and other parts of the world will use different amounts to 10 ppm. And some other work, published work in the scientific literature, has shown that even intermittent ethylene treatment will still give good control.
I thought low ethylene would stimulate sprouting.
I think you'd probably have to be without ethylene over quite a prolonged period, and the ethylene generation systems they've got. Well, perhaps Dirk can tell you how quickly it takes to go from something very low up to, for example, 10 parts per million. My guess is that it's not very long.
Good morning. I'm from Restrain. So this is my day. I'm quite pleased with your results. This is my 10th year that I work for Restrain just on ethylene. Today we are in 36 countries worldwide, and we are now treating more and more processed varieties. You see a lot of differences, and that's what I missed in your story or your results, is to maintain the CO2 levels. CO2 with ethylene is not a good combination. So we always have a protocol to stay below 5,000 ppm. That is very crucial. So if you go above it, then with ethylene in the store, it will affect your fry colors. And that is actually where it can go wrong. And the other thing what I missed is when you take your fry colors, Glyn, is that at the same time that you fry it, let's say you take it out of the store and the same day you fry it? Because there is an effect of regeneration, is that if you do it after 1 week, the fry colors are even better.
Right.
That is the regeneration process of that the sugars will get reduced. And that's also a huge effect.
Right.
So
okay,
if you're
no,
on the limit, then you can stop with the ethylene, and then you flush a lot, and then you get your fry colors really good.
Okay. Well, that's not an experimental protocol that we've employed. I mean, what happens to the tubers in the absence of ethylene for 1 week? I mean, presumably sprouting starts to occur, but
Yeah, but in 1 week it's nothing.
Right.
It's practically nothing. But it will make or break. But for instance, we had one in France, and there was a big processor, and he was oh, you cannot treat it with ethylene because we do not allow. There's a big man in America. He doesn't like ethylene, and we are therefore not allowed to use it. And I say, okay, well, switch it off. See what the effect is, and he can see immediately that the fry colors are dramatically increased.
okay, well, that's very interesting.
Yeah.
Okay, I think as we're running late, I'm going to draw it to a close. So thank you very much, Glyn.